Merry Christmas, guys. Today we're going to do the 2017 February contest silver problem, why did the cow cross the road? So in the problem, the cows are going to be trying to cross the road with the help of chickens. And we're also given the time intervals in which a cow can cross the road, and we're given the times in which a chicken is available to help the cow cross the road. One chicken can only help one cow cross the road, and our job is to find the most amount of cows that can successfully cross the road with the help of the chickens. To understand the problem better, let's take a look at the sample input. So I've already drawn the cows as the blue intervals here, and the chickens as the vertical white lines going through. If you want to see the full solution for this problem, skip to this timestamp right here, because I'm right now going to explain my thought process that led me to the full solution. So for this problem, all we need to do is to assign the cows to the chicken that passes through them. So this chicken passes through this cow, so we can assign this one here. And this cow has a lot of chickens passing through, so we can assign either one. Let's assign this one. And then for this one, let's just assign this chicken right here. So now we've assigned 3 cows to chickens, and that is the best we can do. So the answer for the sample input is going to be 3. So many people right now might think the problem is pretty easy and you can just assign any cow to any chicken that is available to them. However, the sample input is trying to trick you up because it is giving you the input that is the most easiest to solve, and there are basically no wrong solutions here. However, if we make up our own input, say something like this, there is a correct solution now. Because for this cow, we cannot assign it to this chicken because then this cow would have no chickens to assign with. Instead, we need to assign this cow to this chicken and assign this cow to this chicken to get 2. At this point, some people might say, oh well, let's just sort the cows by their end time and assign the first chicken that is available to them. Well, if we just draw the same case, but reversed, we can see that now we're trying to assign this cow to this chicken and this cow to this chicken. So we cannot sort it either by the start time of the cows or the end time of the cows. So right now we feel pretty lost here because we don't know which cows we should do first, and we don't know which chickens should go with which cows. So instead of thinking about the cows here, let's think about assigning the chickens to the cows instead of the cows to the chickens. So let's first look at all the chickens, and let's say for this chicken is paired with this cow, and this chicken is paired with this cow. Okay? And this chicken is paired with this cow, and this chicken is paired with this cow. Now, I already noticed a pattern here. The pattern is that the chicken is always paired to the cow that ends the soonest. So this chicken can be paired with this cow or this cow. However, this cow ends the soonest, so we're going to pair this chicken to this cow. And same thing for here. Let's look at another case that can demonstrate this. So I've drawn another case, and in this case, we're going to first look at the first chicken, and the first chicken is going to be pairing with the cow that ends first, that is available to the chicken. So that will be this cow, ending here. And let's look at the next chicken. The next chicken has 2 cows available to them, and the chicken is going to be paired with this cow because it ends here. And then the last one is going to be paired with the last cow. So there's one more case here, and that's when the 2 cows are ending at the same time. So if we try to pair this chicken with a random cow, because these 2 both end at the same time, and somehow we got the cow here, then this cow would have no chickens to pair with. To avoid that problem there, all we need to do is sort the chickens. So we do this chicken first, and that's going to be paired with this. And then we do this chicken here, which is going to be paired with this. Let's go take a look at the code for this problem. Okay, so in the code, we're first going to read in the C as in the number of chickens and the N as in the number of cows. We're going to construct the chicken, so it's going to be a vector of integers. And we're just going to sort the chickens. And we're going to construct the cows. And the cows are going to be a vector of pair of int, so that means just storing two integers in one element here. And we're also going to have a vector of Boolean visited, so that just means if a cow is going to be paired with a chicken. We're also going to sort the cows just to be safe. So now we're actually going to try to find the chicken and cow pairs. We're going to have a result. It just means how many chickens are paired with cows at the end. And now we're going to cycle through the chickens. We're going to have an integer named minimum end. Just means minimum ending for a cow that can be paired with the current chicken. And the minimum index is going to be the index of that cow. So we're going to cycle through all the cows here. And we're just going to check. If the cow is already visited, we're not going to visit the cow. If the current chicken is bigger than the current cow dot first, which means just the start of the cow, and the chicken is smaller than the end of the cow, we're going to go in. So if it's not visited and the chicken is in the middle of a cow interval, that cow we can maybe pair it with. We're going to check if the ending of the current cow is smaller than our minimum end. So the minimum of the available cows. If it's smaller, we're going to change the minimum end to the current ending, and we're going to change the minimum index to the current index of the cow. Now we're going to check at the end if the minimum index is still -1. That means we have found no cows that can be paired with the current chicken. And in that case, we're just going to continue the loop. Otherwise, we have found something. And if we found something, we're going to add 1 to the result and also set the visited for the one that we found to true. So that just means that that cow is not available anymore because it is already paired with a chicken. And that's basically the end of our program. We're going to print out the result. This problem has a greedy solution, which may be hard to find, but if you can make one correct observation, the code and the logic of this problem becomes very simple. Hope you guys enjoyed the video, and I'll see you in the next USACO problem.